Welcome, my dear friends, to this wonderful and interesting lesson. Imagine walking into a busy clinic one day. A mother waits anxiously with her sick child, hoping for quick treatment. The doctor prescribes medicine, only for the pharmacist to discover it's out of stock. Imagine the disappointment and frustration, not just for the patient, but also for the clinic staff. What could prevent this? A robust inventory management system. Or, let's consider another scenario. A patient needs medicine that must be stored in a refrigerated area to maintain its effectiveness. Without careful tracking and management of storage locations, this medicine could be misplaced or stored incorrectly, rendering it ineffective and potentially jeopardizing the patient's health. Now, imagine a clinic where these problems never arise. Medications are always available, restocking is seamless, and every storage location is meticulously organized. The pharmacist knows exactly where to find the required medicine, and doctors can prescribe with confidence. What makes this level of efficiency possible? A well-organized inventory management system designed to track medications, manage stock levels, and organize storage effectively. This system ensures smooth clinic operations, patients receive the care they need without delay, and resources are managed efficiently. Today, we'll turn this vision into reality by expanding our database to include tables for managing inventory and storage. This addition will not only prevent stock shortages but also improve operations throughout the clinic. We'll work together step by step to design, configure, and implement these database structures, ensuring our clinic system is scalable and efficient. Stay with us, and let's revolutionize how your clinic manages inventory. Learning objectives. By the end of this lecture, students will be able to 1. Remember the purpose of inventory tables and their roles in clinic management. 2. Understand the relationships between medication, inventory, storage, and transaction tables. 3. Apply a modular approach to database configuration using entity frameworks, code-first approach. 4. Analyze the effectiveness of organizing configuration files for better system scalability. 5. Evaluate the benefits of separating configurations and maintaining a clean DB context. 6. Create database tables using migrations and configure relationships dynamically. Lecture outline. To achieve our learning objectives, we'll follow these steps. 1. Introduction to Inventory Management System Goals. What problems does it solve in clinics? Why is an effective database structure essential? 2. Creating inventory-related models, defining tables, medication, pharmacy inventory, storage management, inventory transaction. 3. Configuring relationships and constraints, utilizing clinic context configuration for relationship management. 4. Expanding DB context, adding DB set properties for inventory models. 5. Generating and applying migrations, applying code first principles to implement database changes. 6. Conclusion and evaluation, summarizing the key learnings and previewing the next lecture. Step 1. Introduction to the Inventory Management System Goals. Effective inventory management addresses these clinic challenges. Preventing stock shortages, ensuring medications are properly stored, keeping an accurate record of restocking and dispensing. We will translate these requirements into our database schema through well-designed models and relationships. 1. Medication stores medication details. 2. Pharmacy inventory tracks inventory levels. 3. Storage management defines storage locations. 4. inventory transaction, logs transactions for inventory changes. Step 2. Creating inventory-related models. We'll implement the model step by step, ensuring clarity and structure. We will now create the medication model. The medication model represents medications available in the clinic. Here's the implementation. Public class medication. This class will have the following properties. Public int medication ID gets set. Unique ID for each medication. Public string name gets set. Medication name. Public string description gets set. Short description. Public decimal price gets set. Price per unit. Public date time. Expiry date gets set. Expiration date. Explanation of attributes. Purpose represents clinic medications. Key fields. Medication ID serves as the primary key for unique identification. Name specifies the name of the medication, example, paracetamol. Description provides additional details about the medication's use. Price, useful for billing purposes. Expiry date ensures medications are used before expiration. And will create the pharmacy inventory model. This model connects medications with storage locations and tracks their stock. Public class pharmacy inventory. This class will have the following properties. Public int inventory ID gets set. Unique inventory record ID. Public int medication ID gets set. Links to medication. Public int storage ID gets set. Links to storage management. Public int stock quantity gets set. Quantity in stock. Public date time. Restock date gets set. Last restock date. Explanation of attributes. Purpose links medications to storage locations and records stock levels. Key fields. Inventory ID, primary key for inventory records. Medication ID links this inventory to a specific medication. Storage ID specifies where the medication is stored. Stock quantity indicates the available quantity. Restock date tracks the last time this medication was restocked. Also, we will create the storage management model. Defines various storage locations, such as the pharmacy cabinet or cold storage. Public class storage management. This class will have the following properties. Public int storage ID gets set. Unique storage location ID. Public string storage name gets set. Name of the location. Public string location details get set. Additional details. Explanation of attributes. Purpose describes where medications are stored. Key fields, storage name, location details. And we will create the inventory transaction model tracks all inventory-related transactions such as restocking or dispensing. Public class inventory transaction. This class will have the following properties. Public int transaction ID gets set. Unique transaction ID. Public int medication ID gets set. Links to medication. Public in storage ID gets set. Links to storage management. Public in quantity gets set. Quantity involved. Public string transaction type gets set. Restock or dispense. Public date time. Transaction date gets set. Date of transaction. Explanation of attributes. Purpose. Tracks all inventory movements. D. Key fields. Transaction ID identifies the transaction record. Medication ID links to the medication involved. Storage ID specifies the location of the transaction. Quantity, amount of medication restocked or dispensed. Transaction type indicates the type of transaction. Transaction date records when the transaction occurred. Step 3. Configuring models in separate files. To maintain a clean, scalable, and maintainable structure, each model's configuration is placed in its own file. This approach allows each file to focus on configuring a specific table or entity, keeping the code modular and easy to update. We will create the medication configuration. This configuration defines the schema for the medication table, which stores information about each medication available in the clinic. Sets medication ID as the primary key. Name is mandatory, cannot be null. The name column has a maximum length of 100 characters. Price is mandatory. Detailed explanation of columns. Medication ID. Purpose, a unique identifier for each medication. Role acts as the primary key, ensuring each row is uniquely identifiable. Type integer, auto-incremented by the database. Name. Purpose stores the name of the medication, example, ibuprofen. Constraints. Must be provided is required. Cannot exceed 100 characters. Has max length 100. Importance. Helps identify medications in prescriptions and inventory records. Price. Purpose stores the cost of the medication. Constraints must be provided is required. Importance used in billing calculations and inventory valuation. And we will create the pharmacy inventory configuration. This configuration defines the schema for the pharmacy inventory table, which tracks stock levels for medications stored in various locations. Sets inventory ID as the primary key. Defines the relationship with medication. One medication can have multiple inventory records. Links using medication ID. Prevent deletion of medication if linked. Detailed explanation of columns. Inventory ID. Purpose, a unique identifier for each inventory record. Role acts as the primary key. Type integer. Medication ID. Purpose links the inventory record to a specific medication. Role acts as a foreign key to the medication table. Constraint. Deletion of a medication is restricted. On delete behavior. Restrict. Relationships. A single medication can have multiple inventory records. Pharmacy inventory representing stock in different storage locations. Also, we will create the storage management configuration. This configuration defines the schema for the storage management table, which stores information about the storage locations where medications are kept. Sets storage ID as the primary key. Storage name is mandatory. Maximum length of storage name is 50 characters. Detailed explanation of columns. Storage ID. Purpose: a unique identifier for each storage location. Role: acts as the primary key. Type: integer. Storage name. Purpose: describes the name of the storage location, example, cold storage. Constraints. Mandatory is required. Limited to 50 characters, has max length 50. Importance: helps identify where medications are stored. Relationships. This table does not yet reference other tables, but it plays a crucial role in organizing the clinic's physical inventory. Also, we will create the inventory transaction configuration. This configuration defines the schema for the inventory transaction table, which logs all transactions. Example: restocking or dispensing medications. Sets transaction ID as the primary key. Transaction type is mandatory. Detailed explanation of columns. Transaction ID. Purpose: a unique identifier for each transaction. Role: acts as the primary key. Type: integer. Transaction type. Purpose: specifies the type of transaction, example, restock or dispense. Constraints: mandatory is required. Importance: differentiates between various transaction types for tracking and reporting. Relationships between tables. Medication and pharmacy inventory. A single medication can appear in multiple inventory records. Example: ibuprofen might be stored in both the main pharmacy and cold storage. Pharmacy inventory and storage management. Each inventory record is linked to a specific storage location. Example: a record for insulin might be associated with cold storage. Inventory transaction and medication and storage management. Each transaction links to both a medication and a storage location. Example: a restock transaction for 50 units of paracetamol is linked to main pharmacy. Step 4. Integrating configurations into clinic data context. Integrating configurations into clinic data context ensures that our database knows how to apply the relationships, constraints, and properties defined in each configuration file. Let's walk through this process step by step with a practical example. Setting up the DB context. The clinic data context class is the central point for interacting with the database. It is where we define our DB set properties for each table and configure how these tables relate to one another. Here's the code for the clinic data context class. Explanation of each section. Breaking down the code. DB set properties. Each DB set represents a table in the database. Example: public DB set medication. Medications get set represents the medication table. Public DB set pharmacy inventory. Pharmacy inventories get set represents the pharmacy inventory table. Constructor. The clinic data context class accepts DB context options, example database, connection string, and passes it to the base DB context class. On model creating method. This method is overridden to configure the schema for the database. Step 5. Generating and applying migrations. Once the clinic data context is configured, the next step is to create the database schema by generating and applying migrations. Generate the migration. Run the following command in the Package Manager console. Add migration, add inventory tables. What happens here? Entity Framework scans the DB context class and associated configurations to determine the schema of the database. It generates a migration file that includes SQL commands to create the tables medication, pharmacy inventory, storage management, and inventory transaction, and define their relationships. Apply the migration. Run the following command to apply the migration and update the database. Update database. What happens here? Entity Framework executes the SQL commands in the migration file against the actual database. Now, we want to make sure the tables have been created or not, so we will go to the database and update it. Very good. We notice that the tables have been created successfully. Very nice. The following tables are created. Medications, pharmacy inventories, storage management, inventory transaction. Conclusion. In this lecture, we make the following. On. Designed and implemented the medication, pharmacy inventory, storage management, and inventory transaction tables to manage inventory and storage effectively. 2. Configured each model using explicit configuration classes to define relationships, constraints, and schema. 3. Integrated these configurations into the clinic data context for seamless database management. 4. Generated and applied migrations to create the database schema. By implementing this system, we've ensured that the clinic can efficiently track stock levels, organize storage locations, and monitor inventory transactions, preventing issues like stock shortages or improper storage. Evaluation questions. Can you explain the purpose of each table? Medication, pharmacy inventory, storage management, inventory transaction. How does explicitly applying configurations improve maintainability? Are you confident in generating and applying migrations to update the database schema? Preview of next lecture. In the next lecture, we'll focus on orders and billing integration. You'll learn how to connect patient treatments with financial transactions, completing the clinic's operational workflow. Stay tuned. See you in the next lecture. Bye.